Hello, welcome to today's class. Today we will be treating what we call number-based system. I want you to know that the numbers that we use for counting have a certain base. So we have so many number-based systems. We have numbers in base 1, base 2, base 3, base 4, base 5, base 6, and many more. Out of those numbers, the ones in base 2 and base 10 are the most popular ones that we use. Yes, other number based systems are there, but other bases are there, but the numbers in base 10 and base 2 are the most popular ones. Alright. Our normal counting numbers, the numbers we normally use for counting, are actually in base 10. This number 1, 2, 3, 100, 1000. They are definitely in base 10, but nobody tells you that because um, you are supposed to know. So that's it. So today's topic is about converting numbers from base 2 to base 10. But the thing is, we won't do that first. I want to tell you the names of all the number bases from 1 to 10. So when numbers are in base 1, when numbers are in base 1, there's a name we call them. The name we call numbers in base 1. Numbers in base 1 are called unary numbers. Unary. Unary. Numbers in base 1 are unary. And numbers in base 2, we call them binary numbers. They are binary numbers. The one in base 2 are called binary numbers. Numbers in base 3 are called the ternary. Numbers in base 3 are called ternary numbers. Numbers in base 3 are called ternary numbers. Ternary. And numbers in base 4 are called quaternary. Base 4 numbers are called quaternary. Quaternary. Quaternary numbers. These are the ones in base 4. Quaternary. Numbers in base 5 are called quinary numbers. They are called quinary numbers. Numbers in base 5 are called quinary numbers. Numbers in base 6, they are called senary numbers. Numbers in base 6 are called senary numbers. That's E-N-A-R-Y. Numbers. The numbers in base 7, they are called septenary. Septenary, sorry. In base 7, they are called septenary. Sep. S-E-P. Septenary. Septenary numbers. Septenary in base 7. The numbers in base 8 are called octal numbers. Octal numbers. Numbers in base 9 are called nonary. 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 Are called nonary numbers. And the ones in base 10 are called decimal numbers. Decimal numbers or denary numbers. That's another name for numbers in base 10. Either decimal or denary. So I don't want us to talk much about that. I want us to talk on naming the numbers here. So main topic today is converting numbers from base 2 to base 10 because this is the most popular. These two guys. There's another number-based system for numbers in base 16. I want to add that to the list. Numbers that are in base 16, there's a name we call them. There's a name we call numbers that are in base 16. If the number is in base 16, it has a name, and that's hexadecimal. The name is what? Hexadecimal. So if the number is in base 16, um, the name of that number is what? Hexadecimal. Why hexadecimal? Hexa means 6, decimal means 10. So 10 plus 6, that's going to give you 16. Hexadecimal. So these are the number bases that we have that we're going to be dealing with. So in today's class, we are simply going to be converting numbers from base 2 to base 10. Base 16 numbers are called hexadecimal numbers. So we'll be converting numbers from base 2, converting them all from base 2 to base 16. They're called hexadecimal. Hexadecimal. It's very important for you to know hexadecimal. 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 So today let's convert numbers from this base 2 to base 10, and that's very easy. First, we're going to write the number in base 2. Remember, numbers in base 2 are made up of zeros and ones. Every number base doesn't have digits up to the value. For instance, if your numbers are in base 5, then it's not possible for you to have 5 in a set of numbers that are in base 5. So these numbers here, the one we have on the expression here, is in base 2. This is a number in base 2. Let me write it where there's more space. Let me write it where there's more space. Let me write it bolder. This number is in base 2. This is 1 0 0 1 1. So the base is 2. Now, to convert numbers from base 2 to base 10, first you need to assign powers. You need to assign powers to these numbers, to this digit. So, and you start from the right with a 0. Power of the first one is 0. Power of the second digit is 1. Power of the third digit is 2. Power of the fourth digit is 3. Power of the fifth digit is 4. Now, what do we do next? To convert to base from base 2 to base 10, you just pick this first one, multiply it. Let me show you that with an arrow. Pick this first digit, multiply it by 2. First digit times 2, all raised to the power up here. Okay, then plus second digit c multiplied by 2 raised to power 1, plus third digit c multiplied by 2 raised to power 2, like that. Keep adding them like that. At the end, you add everything and you get your answer. So that's the summary of how you can convert from base 2 to base 10. Now in our subsequent classes, we're going to be converting from base 10 back to base 2. But for today's class, this is what we're dealing with. So let's start now. Let's convert this first. We'll have the first digit is what? 1. Well, let's not start with this last one. Let's start with the first one here. So 1 times 2 raised to the power of what? The first number 1 here, the power is 4. So 2 raised to the power 4 plus 0. Well, 0 times everything is 0, so let's save that time. Put your 0 there plus another 0 there, because 0 times anything is still 0, so let's not waste our time on that. Okay, so 0 times 2 raised to power 3 plus 0 times 2 raised to power 2. Give that 1. So plus 1 is the next digit that is not a 0, times 2 raised to power what? Raised to power 1 plus 1 times 2, 1 times 2 raised to the power of 0. Let me bring that on. 1 times 2 raised to the power of 0. Do you see that? Yes. So the next thing we need to do now is 1 times 2 raised to the power of 4. 2 raised to the power of 4 means 2 times 2, 4 times 2, 8 times 2, 16. That's 1 times 16 plus 0 plus 0, no need, 0 is gone, plus 1 times 2 raised to the power 1, that's 1 times 2 because 2 raised to the power 1 is 2, plus 1 times, now 2 raised to the power 0, you need to remember that anything raised to the power 0 is 1. There's a law of indices that says that any number raised to the power 0 is 1. So this is where some students have some issues. When they say 2 raised to the power 0, they'll say 0. No, it's not 0. Any number raised to the power 0 is 1. So at this point here, we'll have 1 times 2 raised to the power 0. 2 raised to the power 0 is 1. So that's 1 times 1. Now let's do the next multiplication. 1 times 16, that's 16, plus 1 times 2, that's 2, plus 1 times 1, that's 1. Now 16 plus 2, 18 plus 1, that's 19. So at the end, let me write that 9 very well. At the end, 10011 in base 2 is actually equal to 19. 19 in what? In base 10. So we have been able to convert that number 10011 base 2 to base 10. Can you see that? This is pretty easy and very interesting. So we are going again to solve for the second question. We are solving for the second question. Here, this is the number. We call them singly 111011. We are following the same process. 1 1 1 0 1 1. We want to convert it from base 2 to base 10. First, let's put our base there. And secondly, let's assign the powers to the number. Always start from the right with a 0. With a 0 from the right, then move towards the left. 1. So 1 there at the top of the next digit. Then 2. Let me use another color. This is 0, 1, 2, 3, 4, and 5. You see that? These are the numbers that we're going to raise this base to up to 2. We raise this base to the power of these numbers up. So as we always do, we're going to pick the first number, multiply it by 2, then raise to the power of those 5 here. Plus pick the second one times 2, raise to the power of 4. Pick the next number times 2 again, raise to the power of 3, like that till we are done. I can see that's pretty easy. So let's start now. This is 1 times 2 raised to the power of 5 plus 1 times 2. Write that clearly. That's not coming up. 1 times 2 is equal to 4 plus 1 times 2 is equal to 3. Remember, this is 1, 2, 3. Then the next number is 0, so plus 0 times 2 is equal to 2 plus 1 times 2 is equal to 1 plus 1 times 2 is equal to 0. Do you see that? Pick every digit multiplied by 2 raised to the power of the numbers up. So now 1 times 2 raised to the power 5. What will it be? 2 raised to the power 5 is 2 in 5 places, and that's 32. 2 in 5 places should give us 32. 32. Plus 1 times 2 raised to the power 4, that's 1 times 16. Plus 2 raised to the power 4 is 16. Plus 1 times 2 raised to the power 3, that's 1 times 8. 2 raised to the power 3 is 8. Plus 0 times 2 raised to the power 2, that's 0. Let's not waste much time to do that, that's 0. Plus 1 times 2 raised to the power 1, that's 2. I'm not clean this plus. Plus so funny. I have to clean it so that it look more. So plus 1 times 2 raised to the power of what? Of 1 plus 1. Okay. Ink is not coming out very well. Plus 1 times 2 raised to the power 0. So that's the next step now. 1 times 32 is 32. Is equal to, this is equal to. And then 1 times 16, that's 16. That's 16. Plus 1 times 8, that's 8. Plus 0, that's still 0 is gone. 1 times 2 raised to the power 1. I think I made an error here. 2 raised to the power 1. It's still the same, but 2 raised to the power 1 is what? 2. And 1 times 2, that's 2. So it's still the same. Still the same. Plus 1 times 2 raised to the power 0. I want you to know that 2 raised to the power 0 is 1. So that's 1 times 1. And 1 times 1 is 1. So let's add them now. 2 plus 16 is 48. Plus 8, 56. Plus 2, 58. Plus 1 is 59 in base 9 in base 10. So we have been able to convert this number from base 2 to base 10. Do you see that? This is so easy. You can easily do that. Look at this next question here. You can try this next question on your own. Question 4 here. You can pause the video and try this question 4 on your own. I believe with this clear explanation, it shouldn't be too hard for you to solve it. Okay, so let's convert this one. This is going to be the last one. So the power of this one is 0. This is 1. This is 2. This is 3. Oh, but that's not too clear. Let me rewrite the number. Right off is too small, so I can't be able to fix the powers there. So this is 1, 1, 0, 1. No, the zeros are 2, 1, 0. Okay. 0. Okay, so I'm trying to write down. Sometimes the ink misbehaves a bit. Misbehaves a bit, but still the same. We're making progress. We're making progress. So the powers are 0. The powers are 0.